If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. Please share it with all others who might benefit. Let's get started.
In this tutorial, we'll be talking about the Lambda functions. If you are a student of Python, you must have come across Lambda functions, and at the first go, these are not very clear. But the fact is that Lambda functions were created to make our life simple. Let's understand what these are and how these help us. Lambda functions are also known as the anonymous functions, which do not have a name, and they're also called Lambda Expressions. These are the functions that allow us to create concise, unnamed functions on the go. So concise is clear, they probably make the code more compact. They are unnamed, they don't have a name. But what do we mean by on the go? We'll see this as we cover some examples. But let's get started with the common syntax for a Lambda function. So general syntax for a Lambda function is the keyword lambda followed by the arguments. When we say arguments, it means it can expect one or more inputs. And then comes an expression. So if you were to find the square root of a number, you can generally define a regular function with the keyword define, name the function appropriately, use the parentheses, give the input, and return. What are we returning? We are returning that number raised to the power half, which is nothing but the square root. This is how a regular function is defined. And then when we want to call the regular function, we would generally call it by the name that's been defined with and give the appropriate input. So let's say we give the input here as 49, and if we run this, it shows that the square root of 49 is 7. How would this look like in case of a lambda function? So lambda function, as we said, the general syntax is the keyword lambda followed by the arguments, and then we are taking the square root of that. Same thing. Let's just define this. Now the question comes, how do we actually go about calling a lambda function? Because for a general function, you have a name that you can call it with, and you can give the appropriate inputs. Lambda function does not have a name. This keyword lambda is not the name, it's a keyword. You cannot call it by just calling it lambda. In a given large code, you may be using this keyword multiple times. So there's no way to figure out that which lambda is being called. One way to call this is that you store this lambda function in a variable. Let's say we call it find square root, and then appropriately call the lambda function in a similar way as you do for a normal function. But remember the definition. It said we can call the lambda function on the go. What does it mean? On the go means something like, so it was not mandatory for us to store the lambda function in a variable and then only call it. We could directly write that expression and give it the input. This also gives you the same output. Let's take a few more examples. Let's say we want to find the factorial of a given number. So factorial, as you know, if I say factorial of 3, that will be 1 into 2 into 3. So you multiply up to that number starting from 1 up to the number for which you're finding the factorial, inclusive of it. So when we say we're writing a function called define factorial, which takes the input, by definition, the factorial of 0 is 1. And anything beyond that, we will keep on calling it recursively. What is recursive call? We are saying we'll take the value of n, and we are further calling the same function factorial for n minus 1 time. Let's say we want to find the factorial of 5. When I say 5 here as an input, this comes to a stage where it says we will be returning 5 multiplied by factorial of 4. The factorial of 4 in turn would be calling the factorial of 3, so on and so forth. And finally, you get the value, which is 120. How do we write this in the form of a lambda expression or lambda function? Again, similarly, the input that we're giving is n, and then we are using the ternary if-else condition here. We are saying if n is equal to 0, these double equal to signs represent equality. If n is 0, then we should be returning 1. Else, we should be returning n multiplied the factorial of n minus 1. This would give you the same result. So if you see this code is a little more concise, maybe we can emphasize that a little further with the next example. Let's say we are trying to apply lambda function to a list. So we have the temperatures recorded in Celsius, and we want to convert them to the Fahrenheit scale. We are writing a function called define Celsius to Fahrenheit list, which takes the input as the list of temperatures on the Celsius scale. We are initiating an empty temperatures Fahrenheit list, which is where we would want to capture our output. And then we are writing a loop for each value of Celsius in the temperature Celsius, we are doing this transformation. If you know Celsius to Fahrenheit transformation, this is the formula. And for each such transformation, we keep on appending the values to the Fahrenheit list. And finally, we return it. So this was the definition of the function. Of course, if you want to call it, you can call it and pass the appropriate input. And then finally, we are printing whatever we get as the output of this execution. Now, of course, you must realize this looks a little verbose. How do we write it in a concise manner? Well, Lambda function could be the answer. But do we use Lambda functions alone for such tasks? Maybe not. Lambda functions can be conveniently used and are popularly used with higher order functions. What is a higher order function? A function which can take other functions as input and can return other functions as output as well. So we are using Lambda function with a higher order function called map. What are we saying here? Lambda C. So this is basically the input, and then we are just writing the transformation that we want to do. Map function requires the function that we want to apply and the iterable, which is the list in our case. And the output of this, if we only write this much from here to this point, it will just be giving a map object. If you want a proper output, we'll have to put it in the form of a list, and that's what we are doing here. So now you can probably appreciate that compared to this code, this piece here is pretty concise. It's not occupying a lot of space, and it's doing what exactly it's supposed to do. As you know, in data science, data frames are very commonly used to deal with structured data to begin with. And let's say we have a small pandas data frame, which is containing the employee ID, the name, and the salary. And we want to apply a simple rule where we are saying that we want to calculate the bonus for the employees. If the salary is greater than 60,000, the bonus needs to be 5%. But if it's less than 60,000, then it'll be 10%. See how beautifully we can write it in the form of a Lambda function. Lambda salary is the input. And again, we are using this ternary if-else condition, single line if-else condition. The way to read this is that you read this condition first and then see what it returns. If this doesn't hold good, then we go to else and then we see what it returns. Finally, we are adding a column to our data frame, which is called bonus, which simply is obtained by applying the Lambda function to the salary column. So apply is again a higher order function, which is capable of taking another function as the input. So we are applying this Lambda function to the data frame. And as you can see, the output is that you have a new column called bonus, which has 10% bonus in cases where the salary was less than 60,000. But if the salary was greater than 60,000, it shows the bonus as 5%. So we've applied Lambda function to a list, to a data frame, can be applied to a dictionary, which is another very popular inbuilt data structure. Let's say we have different individuals and their performance score in an exam or a test. And let's say we want to find out the top 3 performers based on their scores. In this case, we can use the Lambda function with another higher order function called sorted, where the input is the dictionary items. Now, this dictionary items basically returns you tuples, pairing the keys and values. And then what are we sorting on? We're sorting on the key, which is written in the form of a Lambda function. Lambda x, where we are referring to x index 1. So this index 1 here refers to the scores now. And then we are saying reverse because by default it gives an ascending order, but we want the top scorers, so we'll have to do a descending order and we're taking the top 3 performers from that. So if we run this, we get a pretty sorted output with the help of a for loop, of course, later, because this is more for display. But if we talk about the real work, that was pretty much done to this stage. Lambda functions are also popularly used with another higher order function, which is known as filter. So let's say we have a list of numbers and we want to filter out just the even numbers out of it. We can apply filter, which takes the Lambda function and the list or the iterable in this case. And we are saying if the number is divisible by 2, the modulo of its division by 2 would be equal to 0. So we are only interested in those numbers that satisfy this condition. Note the difference between map and filter. Map does some kind of a transformation to the data. Filter is actually giving you what you exactly need from a given data. So that's the difference. And if we run this, I think it's pretty self-explanatory. You get the even numbers only. But let's also understand when it is not a good idea to use a Lambda function. Let's say we're trying to do, again, a simple task where we have to define a function which says assign grade based on the score. And we have multiple options here. So we have a grade A, which is given to people who scored 90 or above, grade B, who scored 80 or above, grade C, to 70 or above, and D to 60 or above, and else we return an E. Now, if you were to write this in the form of a lambda expression, this is going to be a pretty complex case. Writing it using if-else ladder in a conventional way is still manageable. But if you write it in the form of a lambda expression, it's very complex to read. So keep one thing in mind. Whenever you're using lambda expressions or lambda functions, you want to use them for simple tasks where the legibility or the conciseness of the code is not compromised. This will give you result, but the purpose of using the lambda function gets beaten here. So it is not a good practice to use lambda functions for these kind of tasks. For example, would you write a lambda function to find out a prime number? Can you write that? The answer is yes. Would it become too complex? The answer is yes. And then we should not write lambda functions to find the prime numbers necessarily. And then we should not be writing lambda functions to solve such tasks which are relatively more complex. That was a short tutorial on lambda functions. Hope you get some clarity.